Welcome back to MEF Infinite Edge, episode 8. If you're just tuning in, we're talking about enabling the competitive edge and one of the major drivers of business today, the customer experience. Oh, and I'm still on hold with customer service. I'm kind of getting used to the music now. It's got a good beat. Anyway, it's time to jump into our first of 2 deep dive sessions of the day. Recently, I had the privilege of speaking with Yulia, Product Management Director at Comcast Business, and Kevin Wade, Senior Director and Product Marketing Team Leader, Blue Planet, a division of Ciena, about how application-centric traffic steering enables for deeper granularity, ease of network management, and drives outcome-based decisions. Here is what they had to say. And I'm excited they're both here with me right now. Thank you, Kevin and Yulia, for joining this deep dive. It's been an exciting time recently, not just in the customer experience realm of what we're talking about today, but this is the time of the Olympics. Kevin, have you been watching? And if so, do you have a favorite sport, something that's really intrigued you or been excited about with the Olympics?
Yeah, definitely exciting. I'm a huge Olympics fan myself. It's hard to pick an absolute favorite. Overall, I really enjoy the less popular sports, things like badminton and swimming. And I'd say if I were to pick a favorite, it would probably be swimming and then the relays in particular, because I enjoy the dynamic within the teams themselves, a lot of excitement there, and then the sportsmanship and the competition across the different countries. So the swimming and the relays would be my absolute favorites.
It's been incredible. Such a good show of sportsmanship. You're right. And Kevin, where are you joining us from today?
I am based in Northern California, a little bit north of San Francisco, a small town called Petaluma up here in Sonoma County.
In Sonoma County, not a bad spot to be. And Yulia, sorry, where are you joining us from?
I am joining from Denver area, from Colorado.
Doesn't Denver have like 320 days of sunshine a year? There's a good stat like that, right?
It does. It is one of the sunniest states in the country, so we love it out here. Mm-hmm.
I'm a little jealous here in Columbus, Ohio. And how about yourself? You've been watching the Olympics? Favorite moment?
There are so many. It's so hard to pick. Just seeing all the sports and the sportsmanship and even sports that I'm not as familiar with, such as weightlifting. I was watching with my kids the other day for like 2 hours tonight. Probably one of the first times ever, and I enjoyed that as well. So it's been really fun.
It's been great, and I hope everyone's watched and enjoying it as well. I'm an Olympics junkie. In fact, I've been to 2 of them, and I plan on going to Paris when the next one hits. So if there's someone watching from Paris, I may need a place to stay. Is that all right? I look forward to maybe Airbnb in your apartment or your flat. All right, let's get this started. We got a great deep dive ahead, and I'm going to jump right in. Kevin, tell me, edge compute has become a big topic for network service providers over the past year or so, especially. What's the reason for the growing interest?
Yeah, and I would agree that the industry discussions on edge compute or edge cloud, definitely ramping up, and there's, I think, a couple reasons for that. The first of those would be 5G is becoming more real, right? And 5G, the best way to think about it, at least as far as I'm concerned, is that it's an access network upgrade that the access, broadband access that both individuals and residential customers and enterprise customers will be able to leverage for higher bandwidth and lower latency. So that as that becomes more prevalent, it makes technologies like edge compute more real and more near term. But also there are a newer generation of services that service providers like Comcast are making available that have some responsiveness associated with them and self-service capabilities, things like SD-WAN. Come to mind. That interest and that evolution of these new types of digital services are also spurring interest in edge compute. And then finally, I would say the evolution of cloud native applications applications that are really optimized to run in what you can think of as public cloud infrastructure, or even some aspects of it in private cloud. Also, kind of make edge compute, edge cloud more real. And I would say even maybe one final thing is that if there is one good thing about the current pandemic, it's that it has proven the success of the cloud itself for supporting, business critical type applications. So that aspect of the cloud being proven out as effective, even capabilities we're leveraging today in terms of everybody working from home and leveraging cloud-based applications for collaboration like we're doing here. That also is, I think, driving this interest in leveraging edge compute capabilities from a service provider perspective. So a lot of different facets that are coming together that will enable a new generation of services over the next couple of years.
No, you're right. And I love how you brought out the positive in there as well, and that proof of concept of what's happened for those critical systems. And you just mentioned service providers, and I think they play a big role in delivering these new edge services. Who else do you think is involved?
Yeah, it truly will be an ecosystem, and it has to be an ecosystem for edge cloud, edge compute to work. The service provider does play a critical role. They own that last mile infrastructure and oftentimes much more than that, but certainly that critical last mile. And overall, I think will own the end-to-end service, so to speak. But as I mentioned just previously, these the public cloud providers, the AWSs and Googles and Microsofts of the world will also play a big role, because they'll own and operate these distributed cloud resources that are out in these new edge data center sites. So they will play a role, but those cloud native application providers will also provide a role. I mean, that will be really the new element of this, and that these new cloud native apps will learn to coexist in this hybrid infrastructure, if you will. And then finally, the automation and networking vendors also will play a role in as far as the hardware, and then the automation software that's managing the service needs to be open and scalable and flexible to support this multi-technology environment, if you will. So certainly, yeah, a lot of pieces coming together at the edge, what you can think of as an ecosystem, and a lot of players involved. It's not just a service provider anymore. They will be working in an open way with all of those different participants.
Kevin, spot on. I see the exact same forces that are driving the event of this new edge computing era. But in addition, we also see the Internet of Things, right? All these devices that connect to the internet for either receiving information from the cloud or delivering data back to the cloud. And all of them, many of those devices really generate an enormous amount of data during the course of their operations. So that really is a driver, because potentially the quality of that operation could suffer. And another point that we really see quite a bit from customers is these new applications that require real-time computing power, which I feel that requirement of real-time computing power is more is heavier and more prevalent now that we are redesigning applications either for SaaS or just to further improve the quality of those applications.
Yeah, very true. That's exactly that responsiveness, I think, that I think customers are looking for, and whether those customers are things like enterprises or applications, or like you said, these new devices. I mean, smart refrigerators or thermostats, probably more likely. Other types of devices that we're carrying on our persons, so to speak, all are going to be generating data. Much of it that needs to be processed closer to those different types of customers. So yeah, you're absolutely right.
Thanks for jumping in, Yulia. I'm going to jump back to you for a second, if that's all right, and help me understand, how is edge compute different from current common architectures? And will edge compute take over traditional architectures for most applications? What are your thoughts?
John, so there's 3 common places today where you could place your applications. The traditional approach is to really host that application in a server in your own data center. So this data center is usually within your WAN. It's just another node on your network. So traditionally, that's what we did. And then a few years ago, companies increasingly would instead choose to host the application in the cloud. And with a cloud service provider, either AWS, Azure, Google Cloud, etc. And the reason for that is there's many reasons why cloud has been really adopted from SMBs all the way to large enterprises. But you have the flexibility and the elasticity of the cloud. You have the reliability that the cloud provides, right? Really the backup and the disaster recovery. You have the security, you have the pay by the drink concept versus a kind of an NRC type of, or CapEx type of investment upfront. And all of this is basically, and also removing, I guess there's also the removing of the hassle of really having to maintain an equipment. So think of like either buying a car and potentially paying it off within 5 years and then keeping it for 10 years, or leasing it and every 2 or 3 years getting a brand new car, which sounds nice. I haven't done, but I should think about it. But the trade-off with the cloud really is that now you have the potential of adding latency. So here's the user and here's the cloud, and there's potential back and forth trip that you could potentially add latency that would impact negatively the quality of that experience. And then the cost. The cloud does charge you for anything that comes out of it. So the question is, how long is this end user journey, right, from the user to the application? And does the application require real-time compute? Right. So how long is the journey, and does it require very intense compute power? And it's ultimately, right, do you make the bid or do you transfer the bid? And you kind of weigh up and down. So what has happened is that really it's the cost of compute versus the performance of the data transfer, the performance and the data transfer, right? So what edge computing is really doing is that it's turning things around. It pushes the application closer to the user, right? It brings computation and data storage closer to the devices where the data is being gathered. And hopefully it is minimizing that latency, right? It's improving the customer experience. Is it right for all applications? I don't think so. I think it's really application by application and what the application needs to do in order to provide the best experience.
All right. Well, then what role do you feel, if any, does SD-WAN play in enabling edge compute? How will that play in?
So Kevin mentioned SD-WAN, and I really think that SD-WAN is part and parcel to enabling cloud compute. I'm the SD-WAN product manager, so obviously I will say that. But SD-WAN is about connectivity, right? No matter where the compute resides. So it frees the customer to put their compute where they need it, to have the applications where they need it, and to have the users where they need to be. So how would SD-WAN help? Well, number one, SD-WAN brought application awareness. So we're able on the first packet to recognize what exact application it is and to be able to take an appropriate action based on how critical it is for the customer. SD-WAN also has brought to the front dynamic traffic steering, right? So think of split tunneling, think of different applications. And if it's an application, let us say that it is Vonage or some kind of SaaS voice application, SD-WAN would recognize that it would push it through potentially a gateway in order to ensure best performance from an application perspective so that the code doesn't drop. And then it would go to SaaS. If it is Microsoft Office 365. Well, Microsoft, that is a cloud native application. They have very clearly stated that for those applications, we should not put them on the SD-WAN tunnel. We should actually be able to put them natively because within the protocol, they have built in that capability so that when you're on Teams meeting, when the Teams meeting goes down, it automatically reconnects you. You don't have to go I mean, I always panic when it happens, which is pretty, it's pretty rare because I do have SD-WAN at home, but still it is, it just reconnects you. It is seamless for the user, right? And then the self-healing, right? The fact that SD-WAN can basically poll the health of each of the different circuits. They can determine which is the best circuit and place the packet on the right circuit. So that all of that really, really helps and enables the user to place the application where it needs to be. And then take that, the evolution of SD-WAN into SASE and bring all of these security components, whether it's network security, whether it's content security, whether it's device security, right? We have to secure those devices, and we need to understand who are you, which device are you trying to access from, which application are you trying to access from, do you have access to that application? Should I give you access to that application from this device? So all of this, that was zero trust networking, but all of this basically has taken, SASE has taken SD-WAN and all of these different style of security and has put them into one whole kind of bundle, which really allows our customers to be able to say, okay, let us help you with your applications based on how you would like to run your business.
Yeah, and if I might chime in, John, quickly. So I think that's spot on, Yulia, and really where I think SD-WAN has kind of revolutionized things, relative to legacy services, if you want to call them that, is that both that visibility that your customers are given through the SD-WAN dashboard, so to speak, at the application layer, right? That they want to understand the relation of their applications to their network services, and SD-WAN gives them that visibility and that responsiveness that is only getting them to the point where they want more, right? And that's what edge compute will allow them to do once the network infrastructure is built out with 5G and other upgrades. So yeah, SD-WAN is certainly an inflection point in terms of changing from the old world that was just bandwidth, just connectivity, to the new world where you have visibility and at the application layer.
Visibility and control, right, Kevin? Because you're able to see the data and then you're going to really take an action. And as a customer, you can go through your digital experience GUI and you're able to make application level decisions and policy level decisions. I mean, amazing.
Yeah, I mean, and that's why, and you said it a couple of times, I mean, customer experience is key, right? And that is, customer experience and what is fundamentally different from the old world. Old world, the network goes down and you call, and then it takes how long it takes to get that service back up and running again. Now you have visibility and control. So you're absolutely right.
I'm going to dig into some of the challenges in a sense then. We mentioned some of them, but what kind of challenges, Kevin, will network service providers face operationalizing edge compute-based services?
Yeah, and there will be some challenges there, but there are certainly solutions to said challenges. I think the biggest one, the biggest difference from some of the services that are available today that will exist with edge compute is the services will run over this multi-technology infrastructure, several different domains. We have the public cloud. That's where folks like AWS and Azure and Google Cloud live. You have the network infrastructure and multiple segments of the network. Yes, it's going over the 5G access, but there's also a metro and a core network. In terms of this end-to-end service, there are these different vendors involved when it comes to like the applications themselves. These cloud native applications, including even many SD-WAN solutions are cloud native. So for a service provider, figuring out how to manage the services from end to end that goes across that, by definition, heterogeneous infrastructure, it's a little bit different, right? And because of that complexity, you can't use the legacy OSS solutions, operational support systems that have been used to support things like Sonnet and TDM and T1. So many of that still exists out there. You can't use that OSS and those systems to support these new types of services, edge compute type services, but also things like slicing. You need a new generation type OSS that is built and designed for automation, because automation really will require, these types of services require less and less manual components to them. And so overall, though, I think, just because of the complexity of this end-to-end offering across these multiple domains, people are rethinking, service providers are rethinking the types of systems they're putting in place to support them overall.
Yulia, anything to jump in there or no?
No, I think
okay
Kevin really hit it out of the park this time.
He hits it out of the park a lot.
Every
He's right
time.
on top of this.
Yes, he did.
Well, he does. Well, then I'll jump.
Silly thing to say.
I'll jump back to you anyway. Let's talk use cases. Can you share a few use cases where edge compute solved the customer business problem? And even go deeper, what were the customer desired business outcomes and benefits of that?
Yeah, sure. I would love to. I think this is where the field is still pretty fresh. We still don't know which use cases are going to be real and which ones are going to be lasting. But there's certainly a few that come to mind. I'm not going to go with the self-driving cars that we have all heard. I'll go more real and something that we really, as SD-WAN product manager, I talk to these customers every day, and that's retail. So when you think of retail, right, you think about hundreds of locations, same footprint, very price conscious. As a reminder, they were the first vertical really to adopt SD-WAN. And their most critical applications is SaaS optimization for payment applications. It's point of sale. It's online ordering. Now with COVID, that's absolutely critical that they can get every online ordering because that's expansion of their revenue. And then it's VoIP and UCaaS. They have one or two phones that need to be able to pick up the phone and take that order. So what they're looking at, in addition to those items, there is really a push towards personalization, right? Towards bespoke promotions, right? However, any type of personalization does consume a lot of compute cycles, so that we have to keep in the back of our minds. They're also looking at salespeople, right? Walking with digital tablets, automated checkout options or self-checkout at Costco, right? Store staffing analytics. And ultimately, they're really looking at kind of consolidating the online experience with an offline shopping experience. So when you take all that into account, which is a lot, but they're really going through this digital revolution, the entire vertical is. So think about point of sale transactions, right? So you can do them at the point of sale, or you can do them up in the cloud. So at the point of sale, they will be faster, but it is definitely not as secure. And what if it goes down? Right? If you do them in the cloud, then it's going to take you a while to get to that transaction. There could be latency, and there's a lot of potential points of failure up until you go there and come back. So what if you had in an area, let's say if you are, I'm in Denver, so let's say in the Denver area, for all of the different, chain stores, you have one kind of centralized cloud compute gateway. And that is where it's really short distance, so you're within, 5 milliseconds max, right, to go there, process the transaction. You don't have to invest in compute in all of your different stores, right? I mean, if you think about Starbucks, which if it's Denver or if it's New York City, it seems like there's a Starbucks in every single corner. That could get quite pricey. It's really not very smart. But if you could consolidate that into the middle mile gateway and process those transactions there, now even better, if you could actually kind of combine that processing with a targeted promotion. Oh, I know that you're John, and I know that you came to the Gap store 3 times in the past month, which would be different than if you came into the store 3 times in the past year. Here is the type of promotion, how I need to be able to look you up extremely fast and be able to give you something that's very, very personalized. So that's a really, really great example that we have seen where really cloud compute plays a big, big role, or it could certainly within those type of transactions. Another example is video processing. So video processing extremely intensive in compute power, right? So you have many, many different videos from either remote locations or maybe even stadiums. We just talked about the Olympics, but even think about like sports. We actually have a customer who transmits videos from sports from kids, so that grandparents, especially now with COVID, right, they couldn't go to attend any sporting events. Parents sometimes, right, the mom is working late, etc. So all of that, and when there is one feed, it's a lot easier. But when there's hundreds and thousands of feeds, depending on where the origin is and where that resides, it could really bring it down. The quality, I mean, latency is probably the killer of video. So the solution would be edge computing hardware and services, right, to help really with a local source of processing and storage for many of these systems. So that's another example that we have really seen that works very, very well, and where we have been able to apply this new, not new, but relatively new edge computing architecture, and the customer has been extremely satisfied with it.
No, thank you, Yulia. Great use cases. And you're right. After this, I'm going to run to the Starbucks around the corner in Olympic-like speed to get mine get my little fix. All right, Kevin, I have one more for you. What are some of the important standards initiatives related to edge compute?
Sure, yeah, and there are a number, right? Just like with the example I gave of all these different entities being involved in delivering the ecosystem-based approach for delivering these new types of services, like Yulia was just describing, and across all these different segments of the network, as you would think, there are a lot of different standards involved as well, right? Because different folks look at different pieces. I would be remiss to not lead with the role that the MEF plays here, right? And in that respect, I think a couple different initiatives on the MEF side are involved. The first of those being LSO, Lifecycle Services Orchestration, that looks across, the role that orchestration and automation plays in delivering the end-to-end service and ensuring a good customer experience. So MEF, LSO, but also SD-WAN, which will, as Yulia and I were saying, kind of will lead into an evolution towards these new types of edge cloud, edge compute services. So that they play a critical role. But also, there's a new organization out there, newer, I would say, that is driving the evolution of cloud native services and capabilities, called the Cloud Native Computing Foundation, CNCF. So they play a role. And then the ETSI organization, which looks after globally a number of different telecom standards. They have several that play roles. NFV it plays a role. Something called ZSM, Zero Touch Service Management, very aligned with the LSO concept. And then even more recently, they look after the actual standard called MEC, which stands for Multi-Access Edge Compute, or Mobile Edge Compute. I think they're trying to change the name there, but the MEC standard is probably the most relevant. And then there is a tight alignment and collaboration with 5G as well. So 5G has a set of standards for things like slicing that all are fit under it's 3GPP. Is the standards organization that is related to all things 5G. So a number of different standards organizations all playing a role. The good news, though, is that all of these organizations are, in fact, working with one another, both to make sure their different standards initiatives are complementary rather than competitive, and in fact take use cases like the ones that Yulia described and use those to make sure all the integration points are well defined, because they want to simplify the rollout and the evolution to these types of services. So that's probably the good news, that in the days past, standards used to be a bear, right? Different different vendors and service providers used to almost use them to hash out their own strategies and compete with one another. But now it's more of a collaborative environment. Again, an example of people embracing openness and ecosystems. So everybody's playing nicely together in the sandbox, so to speak, and our customers will ultimately benefit from that.
Kevin, thank you so much for sharing all that. Yulia, thank you for sharing so much of your time. This is a great deep dive. We talked architecture, we talked experience, we talked standards initiatives. We even got a little bit of Olympics and Starbucks in there, which is kind of a perfect transition. You two, I'm going to see how quick I can run, get myself a coffee, and get back here before the next deep dive. And in the meantime, hopefully that incredible host may have a word or two for you. But really appreciate you two sharing your time. Any final comments?
Not for me, John. Thank you, and let's all of us enjoy the Olympics for another couple of days here. So I'm looking forward to that.
Yeah, same here. Thanks for having me.
All right, check out the speed. Here we go. Thanks everyone for joining this deep dive. My name is John, and I will see you shortly.